new, I want to talk about, well, it's not new. It's maybe new to you. I want to talk about vectors. And you'll likely need a calculator. You might want a ruler. And by calculator, you just need sine, cosine, and tangent. So let me draw out.
Mr. Shelton, we can't see.
Nobody can see. I haven't switched it over anywhere yet. But there you go. I've been so impressed with my cool, Zoom game. All these other little things. And I just feel like I've been failing as a teacher this whole week. It's been a bad week.
No, you're a lot better than those teachers.
I appreciate that, but it has been a bad week. So I go.
Somebody told me they don't get into their class until 35 minutes.
Dude, that would suck.
After the bell rings.
Well, that's not happening here. But I'll tell you what I really want to do. I want to set up modules, and you click them and just do the work, and I just sit behind my desk and drink my coffee.
I'm sure that's what teachers do.
I think that's the way to go, But I didn't get into teaching like this. I mean, I got into teaching because, I like kids, and I feel pretty detached behind plastic, but I don't know. I don't know. This year is hard. I know that you guys have heard me say that a lot, and you're probably tired of me complaining about it, but this year is hard. It won't always be like this, but, it's just like it right now. Okay, well, I recorded all of that, so we can replay that on YouTube over and over again. Fun. Mr. Shelton ranting about how hard it is to be a teacher. Oh, we're all whiny about that. There. All recorded so that my listeners in Uganda will know. So, let's talk a little bit about some of the problems that you guys are going to bring with you to this class from your math class. So, if you had pre-calc last year, you're the ones I'm talking to a little bit. And it's the unit circle is what I really want to talk about, because the unit circle has kind of soured you on what I need you to be able to do. You guys who had physics last year, you understand that we're going to be adding together vectors in all sorts of ways. And it's important. Like the first thing we do when we do forces is the resolution of vectors. And so the idea that we're going to have to resolve vectors means we have to use trig, because these vectors can be in 2 and 3 dimensions. And understanding how to resolve vectors is a big part of our class. So we're going to talk about a little bit about just vectors holistically. And I'm going to use velocity vectors for my demonstration today. I first want to kind of bring up the fact that you have been trained to do this in your math class. And unfortunately, your math class kind of made a hard and fast rule that if you want to find components, you do so like this. And then spent the whole time talking about pi 6 and 2/3 pi and all that kind of stuff, which really does not help us at all. So although I have a feeling you know some of these things, there is definitely something lacking. First, they assume that you are always measuring your angles relative to the horizontal x-axis, and that the positive angle direction is counterclockwise. But none of that has to be true. In our class, we will not be making any assumptions like that. For one, the real world doesn't work like that. If the real world designates north this way, north is 0 degrees, already in the wrong direction. And if you think, well, you just got to turn your Cartesian coordinates and you're fine. No. Positive angles on your north, south, east, and west go clockwise. So by definition, if you're talking about north, south, east, and west, and you tell something the wind is 30 degrees, then they think it's 30 degrees to the right of north. So one thing we have to establish is that we don't have reference at all. There is no assumed reference in our class. You have to provide the reference. So we would not call this 30 kilometers an hour at 60 degrees, which is what you would do in math. We won't do it that way. We will establish direction, meaning I would write this as 30 kilometers an hour, 30 degrees east of north. This establishes our baseline direction, north, tells you what direction to turn, east, and how much. So in our class, we need to be very clear that when we're talking about direction, we are stating from where we are taking our measurement. You could say 30 kilometers an hour, 60 degrees north of east. That's fine. And this could just as easily be trying to provide the reference and take our measurements from the reference point. Next, and I've been doing this all day. Well, by all day, I mean 2 hours. And only once did somebody finally have the courage to say, I don't remember or know how you did this. So look, don't sit there and assume that I think you know things. I'm waiting for the person to ask the question. But what I would like you to tell me are these two components. And if you can't, don't keep it a secret. I don't care which way you go about it, but I'm going to be looking for a horizontal component and a vertical component. And if you don't know what a component is, that's telling me something too. So I'm going to give you 2 minutes, and then I'm calling out 2 people. One here, and we don't really care. So let's see, Jason Kim, can you give me one of them?
Is horizontal 30 cosine theta?
Is horizontal 30 cosine theta? No. But that's okay. I don't mind that I'm getting an answer that's not correct. So give me just 1 second, because I did something wrong with the way I did this. I want the class to be able to listen. So I was kind of hoping that I would have somebody who'd want to question this. How many of you don't remember how to do this? Just be honest. Got a couple? All right. So it doesn't really matter how you decide to do this, but I drew 2 sets of components in here, and I did it on purpose so that we could identify which triangle we want to work on. The angle is wrapped around with the red components. Do you guys see that? So I'm going to use the 30-degree angle because that's kind of the triangle I drew. If you want to use the green components, that's fine, but you would have to recognize that this is 60 degrees. So take your pick. I don't care which one you choose to do. I drew both sets of components in there on purpose to see which ones you would use. Now, I'm going to use the red ones, so I'm going to erase that 60 and just do a brief reminder that this is still just good old SOHCAHTOA. So this is hypotenuse, this is opposite, and this is adjacent. I specifically chose to measure the 30 degrees in a way that you could not fall back on last year's pre-calc. That's what I did on purpose. So the horizontal one would be the opposite side. This one right here. That's the horizontal component. The opposite side comes from sine. So this would be 30 sine 30 degrees, which is 15. Any question about that? Go ahead.
Why are you using the opposite? Why is that the horizontal? Like, are we just doing it in relation to the red ones because we're using 30?
I'm not sure I know what
So,
your question is asking.
Okay, so the red versus the green, you pick which one you want to use. And then based on, so we said we're using red, so we're using sine to know that that's the horizontal component because it's going like,
Sideways.
yeah.
Yep. Because otherwise, if we used the green component, it would have been cosine 30 degrees. I'm sorry, cosine 60 degrees.
Gotcha.
Okay? So the vertical one is the adjacent side, which will be 30 cosine 30 degrees, which of course comes out to be, I think, 26. We good? Now it's time for questions. Otherwise, I assume your trig is solid now. So, assuming that that's solid,
Mr. Shelton,
yes.
in this case, wouldn't it be 15 root 3?
Okay.
For the vertical component?
Okay. You got your calculator handy?
Yep.
Can you type 15 times square root of 3? These young whippersnappers. There we go. I mean, it's 25.98 or something like that, but I love how exact your math class wants you to be with the root 3 stuff and stuff like that, but no, we don't need to hang on circumstance here. All right, so now I want to be very clear. We now have the rectangular components. So let's talk about the difference between polar components and rectangular components, because that's what today is supposed to be about. I think you've learned at least 1 or 2 different ways to represent a vector in rectangular components. Probably the most common would be for you to say 15, 26. Right? Ordered pairs? That is a vector notation that you learned like in elementary school. I know you thought that was like a coordinate in the Cartesian coordinate system, but it's also a vector. It tells you the vector location based on the origin being at the center.
Will Miss Jasmine Williams please move her car off the...
So that is not how we're going to do it. The way we have to do it is either using XY notation or IJ notation. And basically mastering loves its IJ notation, right? So IJ notation is the way to go, which will be 15 I hat plus 26 J hat. Who's never seen that before? Oh, good. Now you've learned it. Anything in the horizontal direction is given the I hat, and anything in the vertical direction is given the J hat. Now, I'll explain what those are because you guys are the first group to ask the question. And I've taught this 4 times today, and it bothers me because I usually have people who ask about this, and nobody did earlier today. So either they're really, really smart, know-it-all, or I'm going to bet they didn't because they were scared to ask Mr. Shelton a question.
Give them a pop quiz.
Nah, I'll just be mean to him on Tuesday. Yes?
So which one's which again? The I-hat is horizontal?
Yeah, I'm going to go through it all.
Okay.
So generally, anything in the X direction, we label with I, and anything in the Y direction, we label with J. It is actually okay to just write this as 15 X hat plus 26 Y hat. This is how I learned to do it when I was in college. The IJK notation is the same as the XYZ notation. And in fact, you have learned another way to do it because you've learned 15 plus 26 I. Not I hat, just I, the imaginary number. I don't know if you are aware, but imaginary numbers is another vector format. All we have to have is we have to have a way of expressing our vector as a sum so that you can't add the numbers together by themselves. I can't add 15i to 26j. So that's all this algebra is about. Finding a way to keep those numbers separate. So that if I add a different vector to this, I could add the I parts together and the j parts together. That's what this is about.
What's the purpose of putting the hat above the...
I'm glad you asked. And for you guys at home, she asked, what's the purpose of having the little hat above the I? The little hat means that it's a unit vector in the direction of x. So it adds direction without changing the magnitude. So it's a unit vector. It has a size of 1. And it tells you that the 15 is in the I direction. And the 26 is in the j direction. Thank you guys for asking those questions. I really wish the other classes had not made it sound like they knew all this and that I was boring them. Because I know when I go to do this on Tuesday, they're going to say, well, you didn't tell us that. I asked if you had any questions.
I have a question.
Oh, good.
Oh, well, just kind of like repetition, but you said that the unit vector, it adds direction without changing what?
Without changing the magnitude or the size of the vector. So
Okay,
it has a size of 1. So when you multiply anything by 1, of course, it doesn't change. In this case, it's saying that it's a unit vector. So it's multiplying the size by 1, but only imparts direction. And Ivan, you have a question?
Yeah, I still don't understand why you use sine for horizontal. Like you switch the trig. So for horizontal instead of cosine, you use sine.
Okay, it's because of where I measured my angle from. If I look over in this picture here, ooh, it's so big. Try that again. This is clearly the horizontal component of the triangle.
Mm-hmm.
And this is the vertical component of the triangle. You good there? Well, the angle 30 degrees establishes that this has to be the hypotenuse and this has to be the opposite side. In order for me to figure out the length of the opposite side, I need to use the ratio that puts together 30 degrees with the opposite side, which has got to be sine. Okay?
Yeah.
The problem is that you
Okay.
spent an entire year always making your horizontal components cosine. And that's just not the way it has to be. So I'm not using the axes here at all. I'm suggesting that there is a triangle where the 30 kilometers an hour is the hypotenuse that has two legs that define the right triangle that wraps around it. The horizontal one aligns with the horizontal axis, and the vertical one aligns with the vertical axis. Is that okay?
Yeah, okay.
It's the sound effects that really drive it home. So, and this is, I'm sorry, this is not what I want to do today. What I want to be able to do is something called relative velocity, which is how we actually add vectors together. And we are not going to make it to there because the bell rings like now. So I'm going to stop here before I add something new to this. But James has his hand up. Go ahead, James.
So with the IJK notation, if it were in a
An airplane. Yes, that's an airplane. No, it's not. But it's going to have to be. That's the airplane. And it's flying at a downwards angle of 30 degrees. We would say 30 degrees below the horizon, establishing the horizon as 0 degrees, and it's diving 30 degrees below it. In all of these cases, we